Hi everyone, in this video we are going to discuss why water is unique, or how I like to say it, water is a freak, okay? It is so weird. We are so used to seeing water on a daily basis that I don't think most people appreciate how bizarre water actually is. So let's look at a couple basic properties here and see if you can kind of appreciate or agree with me why water is a freak. So the first thing I want to do here is draw out water. So we know if we were to draw out water properly, we would draw it just like this. So we would say that it has a bent geometry and it has angles that are less than 109.5 degrees. Okay, that's absolutely the most important thing. Now, also, we know that there's a melting point, so it goes from a solid to a liquid at 0 degrees Celsius, and it has a boiling point, so it goes from a liquid to a gas at 100 degrees Celsius. So let's map this out and then compare it to two different things that are very, very similar to water because they have a very similar molar mass. Okay, so we're just going to compare things based on this. So the molar mass of water is about 18 grams per mole. About. Not perfect, but about. All right, so here's our line. We're going to say room temperature is over here. So room temperature is 25 degrees Celsius. So we're going to put 100 degrees Celsius over here, and we'll put 0 degrees Celsius over here. And this is going to be our map of water. So that means before 0 degrees Celsius or under 0 degrees, that water is a solid. So it's in its ice state. So between 0 and 25 degrees, it is definitely a liquid. 25 to 100, still a liquid. And then once we go past 100 degrees, water is definitely a gas. So this is probably a review for you, but if not, that's okay. Make sure you get these numbers down. You have to know them. Now let's look at something that's very similar. So let's look at ammonia. Ammonia has a molar mass of about 17 grams per mole, so very similar, but it has very, very different properties. So let's map this out. 25 degrees Celsius is always going to stay right here. So for ammonia, it has a melting point at negative 77 degrees Celsius. So negative 77, so that means we go from a solid to a liquid at this point. So solid, liquid. Then it has a boiling point of negative 33 degrees Celsius. So we'll put that right here, negative 33 degrees Celsius. So it goes from a liquid to a gas. So a gas above 25 degrees Celsius. So these two things have very, very similar atoms. Very similar atoms. Nitrogen and oxygen are right next to each other on the periodic table. They have a very similar molar mass, but they are very, very different. Look at this. Ammonia is only a solid under 77 degrees Celsius, under negative 77, but it's a liquid between negative 77 and negative 33, and then it immediately pops to a gas at negative 33 degrees Celsius. At the same temperature, water is a solid. Okay, that's weird. That's weird. Water is a freak. It's a freak. That doesn't make any sense. You should be looking at this and be going, this doesn't make any sense. How is that possible? Let's look at something else. Just a single atom with a molar mass of 18 grams per mole. So it's very similar, okay, very similar, same size, but now let's look at these properties. So we're just going to look at a singular fluorine atom. I'm not looking at the diatomic molecule. This is a singular fluorine atom. So room temperature, 25 degrees Celsius. We always want to know relative to room temperature. The melting point of fluorine is negative 219 degrees Celsius. 219 degrees Celsius. So below negative 219, it is a solid. After negative 219, it's a liquid. But right then, right at negative 188 degrees Celsius, it immediately pops and turns into a gas. Okay, so this obviously is not perfectly to scale right here. But we go from a solid to a liquid almost instantly. So fluorine by itself wants to be a gas at any point above negative 188 degrees Celsius. That's crazy. Okay, that's crazy. All three things are very, very similar in size, but they have crazy different properties. So you should be thinking water is a freak. Water is a freak. Water is a freak. This doesn't make any sense. All of these are gases at negative temperatures, and water takes all the way up to 100 degrees Celsius. We have to actually add energy in order to force it to go from a liquid to gas. That's crazy. So what have we learned? The first thing we've learned, water is a freak, or water is unique. Okay, that's fine. First thing we want to know, property number one, you can drive. I call them semi-trucks because that's what I was raised in. So they're from Michigan. Semi-trucks. I think y'all call them 18-wheelers. But you can drive a semi-truck over 6 inches of ice. That's about this much. A semi-truck. One of those giant, giant trucks that would squish you, right? It would absolutely kill you if it fell over and knocked you. You can drive a semi-truck over 6 inches of ice. That's how strong water is. It's a freak. It's a freak. That's weird. That's absolutely weird. That shouldn't happen. That's crazy. Second thing. ice, so water in the solid state or the solid phase, is less dense than liquid water, which is backwards of almost everything else. Usually, your liquid state is less dense than your solid state. And so usually, when you put something inside of itself, a solid into a liquid of the same compound, usually the solid sinks to the bottom immediately. Not the case in water. We know when we drink water, our ice floats. That's weird. That's bizarre. You should start thinking of these things like, why is this so why is this? It's crazy. I'll tell you later, just not in this video. All right, last thing, it boils at 100 degrees. We've already addressed this. Okay, we've already shown how it's a little crazy, but it does not turn into a gas until 100 degrees Celsius, which is absolutely asinine, okay? Keep these three things, these facts in the back of your mind. We're going to keep investigating water and figure out what it is, what is so unique about water that allows for it to have these crazy, crazy properties. All right, so let's finish here with a question. Water is what is it? Did you get an answer? Hopefully you did, because I've said it 100 times in this video. Water is a freak, okay? It's a freak. It is so weird. It's so, so crazy weird. Take care of yourself. Drink water.